Hi guys, welcome to Math Vision tutorial. Today we shall be talking about Rolle's theorem. We shall look at what Rolle's theorem is saying and we shall get a clear picture of what Rolle's theorem is all about. Please stay focused and follow me as I give instructions. What is Rolle's theorem saying? Rolle's theorem is talking about the stationary point of a function in a closed interval. Rolle's theorem is talking about the stationary point of a function in a closed interval. That is, before a function can have a stationary point in a closed interval, it must satisfy three conditions. And what are those conditions? We shall look at the conditions from the definition of Rolle's theorem. Now, Rolle's theorem states that let f be a continuous function defined on the closed interval a, b, that is a comma b. Look at the kind of bracket used here. This is a kind of square bracket, and this is the same thing as this. It means a closed interval, comma, differentiable in the open interval I equals to a comma b. That is, the open interval we are considering here now is a comma b, but a and b are not inclusive, and you can see the kind of bracket that is used here. It is a kind of open bracket. This is to tell us that a and b are not inclusive in the interval, comma, and f of a equals to f of b, which is the third condition. Then there is at least one point c in the interval ab such that f prime of c equals to 0. This theorem is saying that if the conditions of f are satisfied, then there is a stationary point of f which lies between a and b. You can see that the Rolle's theorem is talking about stationary point of a function in a closed interval. Now, we see some examples to get a clear picture of what Rolle's theorem is saying. But before we move into some examples, let's take a brief explanation on continuity. Look at the two figure over here. The first one, this is a graph of the function f of x equals to x over s minus 2. This function will be continuous for every values of x except 2. Why is the function continuous for every values of x except 2? The function is continuous for every values of x except 2 because for every values of x except 2 that you put in this function, you will always get a value for the function. When you put any value for this function, you will get a value for the function other than 2, because by the time you put 2 in this function, you will end up having 2 over 0, which will lead to infinity. And infinity is not a number, infinity is not a real number. So for every values of x other than 2, you will always get a value for the function. And that is why you can see, if you should look at the graph carefully, you will see that as the value of x is approaching 2, there is a break in the graph. There is a O. The graph is not continuous at the point s equals to 2. We have a break at the point s equals 2. We have a O. That means the function is discontinuous at the point s equals 2, because by the time you put 2 in this function, there will be no value for that function at point s equals 2. That's why we have a break over there. That's why we have a O. So the function is not continuous for value of x equals to 2, because when you put 2 in the function, you have 2 over 0, and 2 over 0 is meaningless. There's no value for 2 over 0. So for every values of x other than 2, you will have a real number. You will have a unique value for the value of the function. So the function is only continuous for every values of x other than 2. That means if you are given an interval for this function, if you are asked, is the function continuous? You already know that the point of discontinuity of the function is 2. You will check if the interval given to you is containing 2. If the interval is containing 2, that means the function is not continuous in the interval given to you. So now let's look at the second graph over here. This is the graph of the function f of x equals to 5x minus x squared minus 4. This graph of the function, this function has no point of discontinuity. Why? Because it has no denominator. There is no point at which this function will be discontinuous. The function will always be continuous because for every values of x you put in this function, you will always be getting a value for the function. So the function will always be continuous for any interval given to you because it has no point of discontinuity. Other than this has a point of discontinuity, and the point of discontinuity is is 2. So if 2 is in any interval given to you, then the function will not be continuous in that interval. But for this has no point of discontinuity because it has no denominator at which the denominator will be 0. So here, this function is always continuous for every values of x and for any interval given to you. I believe we have a sharp recall of discontinuity and for a function to be defined. So let's look at some examples on Rolle's theorem. Now, 1. Which of the following functions satisfy the conditions of Rolle's theorem? A, f of x equals to x squared minus 3x plus 2, and the closed interval given to us is 1 to 2. And secondly, f of x equals to 5x minus 3, and the closed interval given to us is 0 to 2. And lastly, f of x equals to x minus 1 over x, and the closed interval given to us is minus 1 to 1. So how do we check if this function satisfies Rolle's theorem? Going back to the definition of Rolle's theorem, we have that the function must be defined in the closed interval AB, differentiable in the open interval AB, and f of a must be equal to f of b. We want to check for those three conditions if those functions satisfy them. So now we start by looking at them. The first one, we have f of x equals to x squared minus 3x plus 2. And the closed interval given to us now is 1, 2. Now, f is continuous on 1, 2. Why? It is very obvious because f of x is a polynomial function. It has no denominator. A function is said to be undefined only when its denominator leads to 0. But in this case, this is not a function in the form of a quotient. It's not having denominator. It's just a straightforward polynomial, and all polynomials are continuous. So f is continuous on the interval 1, 2. For any interval given to you, it will always be continuous because for every value of s you put, you will always get value for the function. Unlike this function over here, for if you put 2 in this function, you will never get a value for the function because 2 over 0 is not a value. When you press 2 over 0 on calculator, you have syntax error. But if you should, for this one, for every values of x, you'll be getting a value for the function. But here, there's a point of discontinuity, which is 2. If you put 2, you can never get a value for that function, and that 2 is said to be a point of discontinuity. And also, this function here has no point of discontinuity. It's a straightforward polynomial. So for every values of s you put, it will always be continuous. It will always have value. So that is why it is continuous on 1, 2. Secondly, the function is differentiable on 1, 2. Why and how do we know? How do we know? We differentiate this function first. By the time you differentiate this function, you will have f prime of x. F prime of x means dy dx. That is, you have to differentiate f of x. When you differentiate f of x, you are going to have f prime of x. And this is a polynomial function. Using the rule for polynomial, you're going to have 2x minus 3. I believe by now everybody can differentiate polynomial functions, trigonometric functions, exponential functions, and logarithmic functions from the basic differentiation video. If you haven't watched it before, you should go back and have a view of it to have the basic understanding for differentiation. So now, differentiate this function first to have your f prime of x, which is 2x minus 3. Since you have this to be 2x minus 3, now you now check for the open interval, that is any values between 1 and 2, like 0.6, like 1.1, 1.2, 1.3, 1.5, and so on. You put it in this function because the differentiation also gave us a polynomial function. We are now going to observe if the function will be continuous for every value of x in between 1 and 2. Yes, the function will be continuous because this function is a polynomial function. The differentiation we got is a polynomial function. So this differentiation function will be continuous for every values of x between 1 and 2. So since it will be continuous, then we say that that function is differentiable. But when we differentiated f of x to get this, if this is not defined for this interval, then we say the function is not differentiable. So now, the function now is what? Is differentiable on the interval 1, 2. And lastly, we want to check our f of a equals to f of b because the theorem says that f of a equals to f of b. And our a in this case is 1, our b here is what? Is 2. What is f of 1? F of 1, from the definition, f of x is x squared minus 3x plus 2. So f of 1 now is anywhere we see x, we replace it with what? We replace it with 1. So following this definition, f of 1 is 1 squared minus 3 1 plus 2. And evaluating this, you are going to have 0. Finding f of 2 from the definition as well, this will be 2 squared minus 2 plus 2. So evaluating these two, we have 0. So we now observe that f of 1 is 0, f of 2 is 0. This implies that f of 1 is equal to f of 2 because they are both 0, 0. Thus, the function f satisfies the condition of Rolle's theorem. It satisfies the condition of Rolle's theorem because 1, f is continuous on the interval because it's a polynomial function. It's obvious. 2, it is differentiable on the open interval 1 to 2 because by the time we differentiate the function, for every values of x between 1 and 2, if we put it in that function, the function will always be defined. So that's why we say that the function is what? Is differentiable on the open interval 1, 2. And we will now find our f of a and f of b. Our f of a here is f of 1, our f of b here is f of 2. Since our f of a equals to f of b, that is f of 1 equals to f of 2, because they are both 0, 0, then it satisfies the third condition of Rolle's theorem. And finally, the function f satisfies the condition of Rolle's theorem. Then we move to the second question, which says that f of x equals to 5x minus 3, and the interval given to us here is 0 to 2. And another way of writing this closed interval is this. Like I told you before, f is continuous on 0, 2. Yes, this is also a polynomial function. It's very obvious. You don't need to disturb yourself. It's a polynomial function because for every values of x, it will always be continuous. For every values of x you put, you'll be getting value for the function. You will surely get a value for the function for every values of x because it's a polynomial function and it does not have denominator. So f is continuous on the interval 0, 2. That is justifiable. We have justified that. Next one, f is differentiable on the open interval 0, 2. Why and how? How to know is we have to differentiate the function first. Differentiating this using polynomial rule, we are going to have 5. And the differentiation now is a constant function. So for this constant function, for any values of s you put between 0 and 1, you'll be getting 5. So you'll be getting value for it. So it is what? The function is differentiable. Function is what? Is differentiable. And lastly, we have to check f of a and f of b. Our a here is 0, our b here is 2. What is f of 0? F of 0, from the definition, f of s is 5s minus 3. So f of 0 will now be 5, 0 minus 3, and this will be 0 minus 3. And 0 minus 3 is minus 3. What is f of 2? From the definition, f of s is equal to 5s minus 3. So f of 2 now will be 5 2 minus 3. So this is 5 times 2, which is 10, minus 3, and this will be 7. So now, since f of 0 is minus 3 and f of 2 is 7, minus 3 is not equal to 7. So this means that f of 0 is not equal to f of 2, hence f fails to satisfy the condition of Rolle's theorem. It only satisfies just 2 of Rolle's theorem, but did not satisfy the third condition of Rolle's theorem. So it fails to satisfy the condition of Rolle's theorem. Now we look at the third one. The third one now is f of s equals to x minus 1 over x. At this point, we have to be very, very careful. We have to check the point of discontinuity of this function. The point of discontinuity of this function is only when is the point at which the denominator will be 0. At what point will this denominator be 0? The point at which this denominator will be 0 is the point at which s equals to 0. Because if s equals to 0, we will have minus 1 over 0. So that is the point of discontinuity of this function now is what? Is 0. We have to note that and hold it somewhere. But for the previous function, this one has no point of discontinuity. This one too have no point of discontinuity. That is why it will always be continuous for any interval. But this one has a point of discontinuity, and the point of discontinuity is the point at which s equals to 0, because at the denominator we are going to have 0. So since we know the point of discontinuity to be 0, this function will not be continuous for every interval, but it may be continuous for some interval that are not containing 0. Because any interval containing 0, this function will never be continuous, because the point of discontinuity of this function now is what? Is 0. If the function is not, if the interval is not containing 0, then the function will be what? It will be continuous in the interval. But if we have interval that is containing 0, then this function will not be continuous in that interval. Now, since we know the point of discontinuity of this function to be 0, we now check the interval given to us. The interval given to us is minus 1 to 1. And another way of writing this is this, like we have been doing before. This means that the values of x is starting from minus 1 to 1. And the values of x here are minus 1, minus is 0.9, minus 0.8, is 0, is 0.1, is 0.2, and so on up to what? Up to 1. So in between minus 1 and 1, we have 0. So 0 is in this interval. So f is not continuous in the interval minus 1, 1, comma. Since it's not continuous, we can conclude from the start that the function does not satisfy Rolle's theorem. But we want to move further to see if the function also is differentiable. Now, how do we know if the function is differentiable? Differentiate this function first. When we differentiate this function, we are going to have 1 over x squared. The differentiation now led to a quotient. 2, it has numerator and it has denominator. So definitely, since it has a quotient, we have to observe the point of singularity, that is, the point of discontinuity, the point at which the function will be discontinuous. And for the differentiation too, this differentiation will be discontinuous at the point where s equals to 0. So in the open interval given to us, is it 0 in the open interval? Yes, 0 is in the open interval minus 1 to 1, because in between minus 1 to 1 we have 0. So since 0 there is there, and when we put a 0 in this function of differentiation, it will be undefined. Then we say that the function is not differentiable in this open interval. So the function did not satisfy the first one, it did not satisfy the second one. So automatically it has failed Rolle's theorem. But we want to check for the last one too. So now we need to check f of a, if f of a is equal to f of b, because this is our a, this is our b. Now, our f of minus 1 here is, from the definition, f of s is s minus 1 over x. So f of minus 1 now is anywhere we see x, we replace it with minus 1. So this will be minus 1 minus 1 over minus 1. And this is minus 2 over minus 1, which is what? Which is 2. F of 1 now, using the definition, f of s equals to x minus 1 over x. F of 1 too will now be 1 minus 1 over 1, and this is 0 over 1, which is what? Which is 0. This implies that f of minus 1 gave us 2, f of 1 gave us 0, and 2 is not equal to 0. This implies that f of minus 1 is not equal to f of 1. Hence, f fails to satisfy the conditions of Rolle's theorem. Even f does not even satisfy any of the conditions. F did not satisfy any of the conditions. So automatically this function fails to satisfy Rolle's theorem. And also this one fails to satisfy Rolle's theorem. The only function that satisfies Rolle's theorem here is the first function. So now let's move to see some further examples, which is the example 2. For the functions above that satisfy Rolle's theorem in example 1, find all possible points C's at which the extremum values occur. Okay, for the functions above that satisfy Rolle's theorem in example 1, find all possible points C's. The reason why we use C's here is because the stationary points in between the interval may be more than one. We may have two stationary points, we may have three. So that's why we use C's at which the extremum values occur. What are extremum value? Extremum value are the minimum value or maximum value. Extremum values are the minimum values or the maximum value. And extremum values only occur at the stationary points. So extremum value only occur at the stationary points. So that means we are to find all possible points C's at which the stationary points occur, or all the possible points C's at which the extremum values occur. We are still talking about the same thing. So now, in the previous example, the only function that satisfies Rolle's theorem is f of x equals to x squared minus 3x plus 2. So that means in between 1 and 2, there's a stationary point. And so that stationary point, in between 1 and 2, there's a stationary point. And that stationary point is the point in which we want to look for now. We need to find the stationary point in between 1 and 2. But for the other function, for this interval, this function, we never have a stationary point in between 0 and 2. And for this function will never have a stationary point between minus 1 and 1. So the first function only is the one that has a stationary point between 1 and 2 because it satisfies Rolle's theorem. So now, the solution now is, since f of x is the only one that satisfies Rolle's theorem, then this is the function that we will only look for the point C of the stationary points. So f of x equals to x squared minus 3x plus 2 with the closed interval 1 to 2 satisfies Rolle's theorem. We know that. So now, what is f prime of x? F prime of x means differentiation of the y dx, that is differentiation of the function with respect to x, and this will give us 2x minus 3 using the rule for polynomial. So now, since we have gotten our f prime of x to be equals to 2s minus 3, that is, f prime of x is 2s minus 3. This implies that f prime of c will be equal to 2c minus 3. It's as simple as anything. Just change x. Wherever I see c, I replace it with x. It's like saying, since f prime of x is 2s minus 3, then f prime of John will be 2 John minus 3. F prime of Esther will be 2 Esther minus 3. So now, f prime of c will be 2c minus 3. Since the above function satisfies Rolle's theorem, it follows that f prime of c equals to 0, because that is what Rolle's theorem states. Rolle's theorem states that if the function satisfies the three conditions, then there's at least one point C in between A and B such that f prime of c equals to 0. So now, since it satisfies Rolle's theorem, then f prime of c of that function will be equal to 0. So now, since it satisfies Rolle's theorem, we are going to set f prime of c to be equal to 0. And our f prime of c is 2c minus 3. We are just going to set 2c minus 3 to be equal to 0. Then 2c minus 3 equals to 0, 2c equals to 3, and therefore c equals to 3 over 2. Thus, the required point is c equals to 3 over 2. and 3 over 2 is the same thing as 1.5. So the point that Rolle's theorem is talking about that is lying between 1 and 2 is 1.5, because you can see clearly that between 1 and 2 we have 1.5. So 1.5 lie between 1 and 2. So the point we are talking about now is what? Is the point 3 over 2, which is 1.5. So now I have some practice questions for you to solve. And just goes the question. 1. Verify if the following function satisfies Rolle's theorem and find the point C at which the stationary point occur. Now the first function is f of s equals to x squared plus 5s plus c, and the closed interval given to you is minus 3 to minus 2. And secondly, f of s equals to x minus 1 over 3 plus x, and the closed interval given to you is minus 1 to 1. And c, f of s equals to 2s squared minus 8 minus 1, and the closed interval given to you is minus 1 to 3. So now what you have to do is to verify if they satisfy Rolle's theorem. After you verified if they satisfy Rolle's theorem, then um, you are going to find the point C at which f prime of c equals to 0. Remember, if any of the function did not satisfy Rolle's theorem, that means there is no point c in between the interval ab. There will be no point c. It is only when it satisfies Rolle's theorem that there will be a point c in between a and b. So now practice this question, and if you have any question, any problem concerning this class, you can drop it in the comment box below. Please don't forget to subscribe to this YouTube channel, like and watch the video, and also don't forget to click on the notification bell. I am going to see you in my next video.